Open your book to page 327. This lesson is on vector equation of a line. When you have a vector in space, a vector is like a line, and in space it can be formed by two planes, intersection of two planes. For example, you can have like this vector over here. Okay, so this would be an example of that. Now you can see that there would be infinite number of planes that can intersect to get these. Okay, so the one we're looking for would be the one that is perpendicular to the coordinate planes. Okay, and those planes are called projecting planes. And the planes that the equation that deal with these projecting planes would be is called a symmetric equations. So symmetric equation would be the equation of that, which is like a perpendicular to the coordinate planes. Okay, so let's go over how to get those equations. So in example 1, it says find a symmetric equation that represents a line passing through the point. So you got point 2, negative 1, 3, and it's parallel to V equal to 2I minus 5J plus 6K. So you're looking for equation of the line that in space that goes through this point is parallel to that. Now these are your direction numbers. So what you need to have, again, get your equation ready. So you see these direction numbers. This goes to the denominator. Okay, so you got 2, negative 5, 6. So you're going to get 2, negative 5, 6. And then since you have to go to this point, then you have to use this point. So from here you're going to get x minus 2. Right, just like when you're writing the equation for the intercept points, right? And so this would be y plus 1, and you get z minus 3. Okay, and so this would be your symmetric equation. Okay. And next, you have to find the parametric equation. Okay, so this is symmetric. This is a symmetric equation. Now, parametric equation means sometimes it's kind of too complicated to deal with all three variables at one time. So sometimes you're going to deal with one variable at a time, and especially in physics with the projectiles. Okay, but for here, so parametric equation is you set each one of these equal to another variable, and in this case we use the t. Okay, so this is parametric equation. So you just set each one of these equal to t, and you solve for each individual variable. So now that you deal with one variable, each individual variable. Okay, so you have x minus 2 over 2 equal to t, and you have y plus 1 over negative 5 equal to t. By the way, in the book, it has a mistake. It has a positive. It's supposed to be negative, right? And then you have z minus 3 over 6 equal to t. Then after that, you solve for x. So x minus 2 equal to 2t. Then you plus 2. So you got x equal to 2t plus 2. Over here, do the same thing. Y plus 1 equal to negative 5t. Then you minus 1. So you got y equal to negative 5t minus 1. Okay. And for z, you multiply, you get z minus 3 equal to 6t plus 3 plus 3. So you get z equal to 6t plus 3. And so these are your parametric equations. Okay. Okay. Now let's go to example 2. On page 328, example 2. So each example is like one additional step that you have to do. So over here you're looking for a line passing through those 2 points. So P1 is at 2, negative 4, 5, and P2 is negative 1, 3, 1. And you're looking for the symmetric equation. So to look for a symmetric equation, you need to find the vector has this direction first. So you need to go and find the vector first. So P1, P2, so you have to minus, right? So negative 1 minus 2 give you minus 3i. 3 minus negative 4 give you plus 7j. 1 minus 5 give you minus 4k. And so from here, again, get your equation ready before you write anything. So you got negative 3, 7, negative 4. So this goes on the denominator. Those are your directions. And you want to go through one of the points. So we're going to use this point. So from here, you're going to get x minus 2. Right, from this is going to be y plus 4. And you're going to get z minus 5. So this would be your symmetric equation. And that's it. Okay, let's go to page 329, example 3. It says, write the equation of the line passing through those 2 points. Okay, so you can just same thing, right? So P1 is 2, 6, 4, and P2 is 3, negative 2, 3, negative 2, and 4. So again, first you need to get your vector. So P1, P2. Okay, when you subtract, you're going to get I. This minus I give you minus 8j. This minus is 0, so they don't have anything over here. Now, since there's nothing over here, when you write your equation, you only have I and j. So you only need to I and j. Okay, because in this case, you can see that when there's no k, it means k is a constant. That means in this case, z is always equal to 4. Right? Notice z is always equal to 4. That's why you don't have the direction vector over here. So over here, you're going to have, so over here you're going to get 1 and negative 8. So you're going to get 1 and negative 8. And if you use this point over here, you're going to get x minus 2, and you're going to get y minus 6. Okay, so this would be your symmetric equations. Now, if you're missing two variables, if you have only one direction number, then you will not able to have a symmetric equation. Okay, let's go to example 4. Okay, example 4. It says find the equation in a symmetric form of the line intersection of the 2 planes. Okay, so you have equation of 2 planes. So you got x plus y minus z minus 7 equal to 0, and you have x plus 5y plus 5z plus 5 equal to 0. So from here, basically what you have is this is a plane like this. Okay. And this one is like this. So this one would be like that. So you're looking for intersection of these two, which is a line, right? Intersection of 2 planes is a line from your geometry. Okay. And you want to write it in using write it in a symmetric form. Okay. Now, when you do this, right, what you want to do is you want to set one of the variable equal to you want to set one of the, it's easy if you set one of the variable to 0 and look for one of the points. So again, set one variable equal to 0, you can find one point on here. Set another variable equal to 0, you can find another point. Okay, so basically looking for P1, P2. Okay, and you become like previous problem. Now when you're choosing the variable to set equal to 0, the math will be less messy if you choose a higher coefficient equal to 0. So for example, like this one, if you let x equal to 0, sometimes the number can get very messy. So you want to choose a higher coefficient to make it equal to 0. So in other words, you want to let y equal to 0. Okay, so for y equal to 0, you're going to get x minus z minus 7 equal to 0. And then you have x plus 5z plus 5 equal to 0. Then from here you have to solve, right? So times this by negative 1. So you got negative x plus z plus 7 equal to 0. And you put this over here. So use elimination method. So just work it out. So this cancel out. So you got 6z plus 12 equal to 0. So 6z, so minus 12 on both sides, right? You can write it down so you don't mess up on the sign. Divide by 6. So z equal to negative 2. So I'm going to circle my information so I can look for them. Okay. So from here, I need to solve for x. So I can use this one. So x plus 5 times z plus 5 equal to 0. So x minus 10 plus 5 equal to 0. So x minus 5 equal to 0. X equal to 5. So my P1 is going to be at 5, 0, negative 2. Okay. So now to find P2. So again, I'm going to let z equal to 0. Right? I can set a higher coefficient variable to equal to 0. If you set x equal to 0, you might come up with a messy number. So that's z equal to 0. So you got x plus y minus 7 equal to 0, right? And so from here, you get this. From here, you get x plus 5y plus 5 equal to 0. And I'm going to multiply this by negative 1 to eliminate the x. So put this over here. Again, I'm just using elimination method. So this one is kind of a lot of steps. So I get 4y plus 12 equal to 0, minus 12 on both sides. I'm working kind of fast because these are basic algebra you should be able to handle, right? So y equal to negative 3. Again, I'm circling my information so I can find my information quick. So I need to look for x. So x plus, you can use this equation actually a little bit faster, but let's just use this one, doesn't matter. So you got x minus 15 plus 5, 15. Again, watch out for careless mistakes. So x minus 10 equal to 0. Right? So x equal to 10. So that's my P2. My P2 is 10, negative 3, 0. Now, once I get P1 and P2, it becomes like the previous problem, right? Okay. So I need to get vector P1, P2. Okay, so vector P1, P2, when you subtract, you get 5i minus, so you get minus 3j plus 2k, right? So 10 minus 5 give you 5, negative 3 minus 0 give you minus 3, 0 minus negative 2 give you plus. Okay. So from here, then you can write your equation, right? So you're going to get 5, negative 3, and 2, right? And then if you use this point, you're going to get x minus 5, y minus 0, and z minus negative 2 give you plus 2. And that would be a symmetric equation. Okay, so you got to, so in this case, again, you have to do this to get your point, okay, get your P1 and P2.